Every electric car on the road right now has a dirty secret hidden inside its motor. Metals ripped from the earth through one of the most toxic mining processes on the planet, and the entire EV industry depends on them. But at Tesla's 2023 Investor Day, the company announced something that made engineers across the world pay attention: a next generation permanent magnet motor using zero rare earth materials. This isn't a small upgrade. If it works at scale, it could break a chokehold that has quietly controlled the EV industry for years. And Tesla isn't the only one racing to get there. Here's why this matters far more than anyone is telling you. Let's start with what's actually inside your EV's motor. Most electric vehicles today, including Tesla's own Model 3 and Model Y, use interior permanent magnet motors. Embedded inside those motors are powerful magnets made from rare earth elements, specifically neodymium and dysprosium. These magnets create a constant magnetic field that makes the motor compact, efficient, and powerful. Sounds great. So what's the problem? The problem is where these materials come from. China controls roughly 60% of global rare earth mining and approximately 90% of rare earth processing. That means nearly every EV manufacturer on Earth is dependent on a single country's supply chain for a critical motor component. This isn't theoretical risk. In 2010, China temporarily restricted rare earth exports during a diplomatic dispute with Japan. Prices spiked over 1,000% almost overnight. Industries panicked. And that was before EVs were mainstream. Now scale that risk to a world where hundreds of millions of electric cars need these materials every year. But cost and politics aren't even the full picture. Rare earth mining is environmentally devastating. The extraction process generates radioactive waste, toxic acid runoff, and massive landscape destruction. For an industry that sells itself on being clean, that's an uncomfortable contradiction sitting right inside the motor. So the EV industry has a dependency problem. The motors need materials that are geopolitically concentrated, environmentally destructive, and price volatile. And until recently, no one had a production-ready solution. That's starting to change. When Tesla announced a rare earth-free motor, a lot of people assumed it just meant swapping one magnet for another. It's more fundamental than that. There are several real engineering approaches being developed right now, and understanding them is key to seeing why this shift matters. The first approach is the externally excited synchronous motor, or EESM. Instead of using permanent magnets on the rotor, an EESM uses an electromagnet. Electric current is fed to the rotor, either through physical brushes or wirelessly through induction, creating a magnetic field on demand. No rare earth magnets needed. BMW is already using this technology in its fifth-generation e-drive system, powering the iX and i4. It works, it's real, and it's in production vehicles right now. The second approach is the switched reluctance motor, or SRM. This design is even more radical. The rotor has no magnets and no windings at all. It's just shaped steel. The motor works by pulling the rotor's steel teeth into alignment with electromagnetic fields generated by the stator. SRMs are mechanically simple, extremely robust, and cheap to manufacture. The historical problem was noise and vibration, a rough, uneven torque delivery. But modern high-speed power electronics and software control are solving that problem. Companies like Mahle have developed magnet-free motors based on this principle that are being tested for production vehicles. The third approach involves advanced ferrite magnets. Ferrite is cheap and abundant, unlike neodymium. The trade-off is that ferrite magnets are significantly weaker. To compensate, engineers are redesigning motor geometry, using techniques like flux concentration and optimized rotor shaping to extract more performance from a weaker magnet. This lets you keep the permanent magnet architecture while eliminating the rare earth cost and supply risk. Tesla hasn't publicly confirmed which exact approach its next-gen motor uses, but based on their Investor Day presentation, they are targeting a permanent magnet motor that achieves zero rare earth content, likely through advanced magnet chemistry and motor geometry redesign. The goal is to match current performance without the dependency. And here's where the software layer becomes critical. In any of these designs, intelligent motor control software can dynamically adjust the magnetic field strength, torque delivery, and energy consumption in real time. When you need maximum acceleration, the system delivers full power. When you're cruising on a highway, it dials back to conserve energy. This software-hardware integration is what makes rare earth-free designs competitive with traditional permanent magnet motors. The motor isn't just running on electricity, it's running on algorithms. Here's what most coverage gets wrong. This isn't just a Tesla story. BMW is already shipping rare earth-free motors in production vehicles. Renault has partnered with Valeo and Siemens to develop wound rotor motor technology. Mala has built a magnet-free motor prototype designed for mass production. Chinese manufacturers are investing heavily in alternative motor designs because even they recognize the risk of supply concentration. Toyota has also been researching rare earth-reduced and rare earth-free motor designs for years. When Tesla made its announcement, it wasn't creating a new race. It was publicly entering one that was already underway. But Tesla does have one significant advantage: vertical integration. Tesla designs its own motors, builds its own factories, writes its own motor control software, and manufactures at scale. That means if Tesla develops a rare earth-free motor that works, it can move from prototype to millions of units faster than almost any competitor. Most legacy automakers rely on suppliers for motor components. Changing their motor design means renegotiating with suppliers, retooling production lines, and revalidating entire vehicle platforms. That takes years. This is where the real competitive pressure builds. If Tesla ships a rare earth-free motor in a mass-market vehicle and delivers the same range and performance, every other automaker will face a difficult choice: keep paying for rare earth supply chains with all their cost and risk, or undertake the expensive, slow process of redesigning their own motor systems. Let's talk about what happens if rare earth-free motors succeed at scale, not just for Tesla, but across the industry. The first effect is cost reduction. Rare earth materials contribute meaningfully to motor cost, and their price volatility makes production budgeting unpredictable. Remove that variable and motor costs become more stable and potentially lower. This doesn't make a $45,000 car suddenly cost $20,000, but it removes one barrier on the path to genuinely affordable EVs. The second effect is supply chain liberation. Right now, if you want to build EV motors, you need access to rare earth materials and processing infrastructure concentrated in one region of the world. Eliminate that requirement and motor production becomes possible in far more locations. New factories can open in regions that previously couldn't participate. This could be transformative for EV manufacturing in Southeast Asia, India, Africa, and Latin America. The third effect is accelerated fleet adoption. Today, logistics companies, taxi operators, and delivery networks want to electrify, but are held back by vehicle costs. If motor production becomes cheaper and more scalable, fleet electrification could accelerate dramatically. Thousands of delivery vans and commercial vehicles switching to electric doesn't just reduce emissions, it proves the economic case for EVs beyond personal transportation. The fourth effect is geopolitical rebalancing. If the EV industry no longer depends on rare earth supply chains controlled by a single country, the strategic leverage shifts. Nations that invest in motor manufacturing, innovation, and production capacity gain influence. The power moves from resource holders to technology developers. This isn't about one company building a slightly better motor. It's about the entire EV industry confronting a fundamental vulnerability and engineering its way out. The technology is real. Multiple companies are pursuing it. Some are already shipping it. The question isn't whether rare earth-free motors will happen. It's who will scale them fastest, who will make them most efficient, and who will be too slow to adapt. The next chapter of the EV race won't be one on battery specs alone. It might be one inside the motor. If you want to stay ahead of shifts like this before they hit the mainstream, subscribe now. The next video goes even deeper.